Hi everyone. Today we are going to have a discussion about stacks. Stack is a popular data structure in programming languages. A stack is basically a user-defined data structure. In programming languages, there are many built-in data types. Every programming language provides built-in data types, but a stack is a user-defined data structure. That means it is created by the user. Let's see in detail what stack is all about. A stack is called LIFO or Philo data structure. What do we mean by LIFO or Philo data structure? It is last in, first out, or first in, last out. Why do we call a stack a last in, first out, or first in, last out data structure? Sometimes it is also called push down data structure. It is because the item that is entered first inside the stack is the item which is removed last from the stack. Item which is pushed inside the stack first is the item removed in the last. Yes, you have heard correctly. The operations of insertion and removal of element are called push and pop operation respectively. Push operation means pushing element inside the stack. Pop operation means removing items from the stack. For example, in this case, item number 1 is pushed inside the stack. This will be the first item inside the stack. Item number 2 will be the second element which is pushed inside the stack. Item number 3 is the third element which is pushed inside the stack. This is the last item which is pushed inside the stack. Now when we are going to pop the elements out, item number 3 will be the first one to be popped, and then item number 2, and then item number 1. So that is why stack is also known as last in, first out, or first in, last out structure. Now let's see some real life examples around us about the stacks. Can you see this stack of stones which you may usually found around the beaches or in the hilly areas, or there are many games that children play by making a stack of stones. So it's a stack. Another example, yes, you can see it behind me, a stack of books, and of course in banks or in financial institutions you may have seen this kind of visuals where the coins are stacked, stack of coins. Yes, so let's now see what are the applications of stacks inside a computer, where it is used inside the computer. That is more interesting. Now stack is used in a variety of applications in computers. The first application that we can think of is reversing a string, where a string can be reversed. Well, let's see how. Consider the string Python, which we want to print in reverse order. Now, first of all, this string has to be pushed inside the stack character by character. So this P is pushed inside the stack, then Y is pushed inside the stack, it comes over P. Then T is pushed inside the stack, it comes over Y. Then H is pushed inside the stack, it comes over T. Then O is pushed inside the stack and it comes over H. Then N is pushed inside the stack and it comes over N. So we have entered the string Python. The characters are stacked one over another. Now how is it reversed? For reversing this string, what do? We start popping out the elements. That means N is the first character to be popped out, and we send it to the print area, or we send it to the monitor, output screen. Then O is popped, O is sent to the monitor. H is popped, H is sent to the monitor. T is popped, T is sent to the monitor. Y is popped, Y is sent to the monitor, and P is popped, P is sent to the monitor. And as a result, you can see that the string has been reversed. So this is one of the application of stack. Another application of stack is handling mathematical expressions in programming. Now, we as human beings, we can easily understand an expression of this kind. That is, if you carefully read it, 10 plus 20 into 30 divided by 2 minus 5. Now this expression is written in the form which is called infix notation. Now this infix notation is the form which we usually use in our daily life. In registers, in piece of paper, when we write an expression, we write it like this. This expression is very simple for human beings to understand. But believe me, this expression is very difficult for a computer to evaluate. A computer cannot evaluate this kind of expression easily. So what is done? This expression is converted into another notation which is called postfix notation. Now in postfix notation, the operators which you have seen in this infix notation, these operators are placed between the operands. For example, plus is placed between 10 and 20, multiplication is placed between 20 and 30, division is placed between 30 and 2, minus sign is placed between 2 and 5. So the operators plus, into, divide, minus, they are placed between operands. What are operands? 10, 20, 30, 2 and 5. These are operands. So in infix notation, these operands are placed between these operators are placed between the operands, but in postfix form, the operators are placed after the operands. Yes, 10, 20, 30 into 2 divide plus 5 minus. Now this conversion from infix to postfix form is based upon the precedence of operator, the priority of an operator inside an expression, which operator should be evaluated first, and of course an algorithm for converting this infix expression into postfix form. This algorithm takes the help of a stack for converting an infix expression into postfix form. A stack is used over there, and also to evaluate this expression, again stack is used. So let's try out an example. We have an example 10, 20 plus. This 10, 20 plus is written in postfix form. That means the operator plus is placed after 10 and 20. How a stack is going to evaluate it? To evaluate this expression, we will start reading this expression from left to right. The first expression is 10. So 10 is sent or pushed inside the stack. Then the next expression is 20. 20 is again pushed inside the stack. The operands, basically, they will be pushed inside the stack. But when we encounter plus, when plus is encountered, plus is an operator, and plus is a binary operator. That means it operates upon two operands. Last two operands which were pushed inside the stack are popped. That means 20 and 10, they are popped, and this plus is applied on 20 and 10. So 20 plus 10 is equal to 30. The result is generated. This result is again pushed back inside the stack, and the process continues till the stack becomes empty. That means all the operands are computed, and final result is pushed inside the stack. So this is how a stack is used to evaluate a postfix expression. The stack is also used in gaming or artificial intelligence based programming or algorithms, especially for backtracking. What is backtracking? Backtracking is, let's say we are playing a game of chess, and I make a move. I make an initial move from an initial state. Now there are a number of possibilities available before me. I can go to the right, I can go to the left, I can go straight. There are a number of possibilities available. Now I may follow a path, and at the end of that path I will come to know that this path is not fruitful for me. I will not be able to win the game. So what would I like to do? I would like to start from the initial state again, but then there will be no way available that I can come back to that initial state. But if a computer is playing that game, computer can do that with the help of backtracking procedure. And in this backtracking procedure, it can easily come back to the initial state. Now in advance, when suppose you are playing the game with the computer can evaluate different moves and different paths, and it can easily analyze that which path will be most fruitful or most beneficial so that it wins the game. Now how does it do that? It does that with the help of structure, something like tree structure. Let's say there is a root node in this structure. This root node is an initial state from where the computer starts playing the game. Now there are two different paths available. You can see here the computer can follow any path. It can follow the path of A or it can follow the path of B. Let's say the computer decides to follow the path of A. Now how is it going to use a stack in this game? First of all, the address of this root node or this initial state is pushed inside the stack. So it comes inside the stack and it moves to the next node, that is node A. Now address of the node A is pushed inside the stack, then it moves to the node B. Address of node B is pushed inside the stack and goes to node C, and address of node C is pushed inside the stack. Now after C, the algorithm realizes that this path will not be a fruitful path and it is resulting in a failure kind of situation. So what will it do? It will backtrack. How this backtracking occurs? Now from the stack in which the addresses are stored, this address of C, which was the last node which was pushed inside the stack, the address of that last node is popped and the program goes back to the C node. Then the address of the node B is popped and the program goes back to the address of B node. Then node A is popped, address of the node A is popped, and the program will go back to node A. And finally the address of root node is popped and the program will go back to the root node. That means the root node, which was the initial state, and from this initial state the program can again follow the next path which was available, the path of D. It can easily follow that, right? So for backtracking, stack is used heavily in gaming. Now this is an area where stack is used heavily: function calls and return statements and recursion. Now let's assume that we have three functions: function f1, f2 and f3. From function f1 we are going to call function f2. From function f2 we are going to call function f3. Now once the statements of the function f3 gets executed, the control has to return to function f2, and once the statements of the function f2 gets executed completely, the function has to return to function f3. The control of the program has to return to function f1, sorry. Now in how stack is used, let's say function f1. Function f1 calls function f2. But before the control jumps to function f2, the next instruction, the address of the next instruction is pushed inside the stack. And then the control jumps to function f2. Now function f2 calls function f3. Again, the address of the next instruction in the program is pushed inside the stack and the program control jumps to function f3. The statements written in function f3 gets executed, and now the function has to return, the control has to return to function 2. How will it return? It will pop the address stored in the stack and goes back to that location. So the control returns to function f2, the statements of function f2 will execute, and now the control will return to function f1. How will it return? The address from the stack will be popped and the program control will jump to the address of function f1. This is how the stack is used in call to functions or return statements. So that is all for now. We'll be meeting in next video very soon, and we'll be learning programming stack in Python programming language, how to code a stack in Python programming language. Till then, take care. Goodbye.